already working with us or assigned to our team. And we have some of our peers also on the line. So you'd be able, if there's something that you take away from today that you want to do jointly with us, let us know and we'll be able to follow up with you one-on-one.
Absolutely. All right, so with that, let's just take a look at the agenda for today. About the first 15-20 minutes, we're going to be making a case for why you should modernize. The real distinction between migration and modernization is actually quite large. And so we're going to cover a lot of that, just the first part. Then we'll switch over to the Well Architected Framework. We'll briefly cover how it helps you, as well as how you should think about your services. You can apply it definitely to your existing migrated infrastructure, but you can use the same principles to help you figure out how to use the services in a modern architecture. In the third section, we're going to be talking about how customer success can help you. So there's lots of programs that are available for us in terms of when we're working with partners and customers. So we're going to be covering that for about not 15 minutes, but maybe like just under 5, just around 5, I think. And then the last portion is actually going to be quite technical. We're going to be looking at various Azure services and how they map to the pillars, the WAF pillars. Now, there's actually, if you follow that link, that QR code on the top right, there's actually a link to the demos folder. We have a lot of demos that we have uploaded to that GitHub repository for now. We're going to be adding more over time, but we would not have enough time to go over those videos during our presentation today. So we're going to do a very brief overview of those videos, but for more content and more greater depth, they're available for you to view offline. So having said that, let's jump right into why we want to modernize. Jerome?
Perfect. Yes, thank you again, Russ. So I'm going to spend 10 minutes on what the motivation and specifically a focus on what the business drivers are for modernizing applications. And then we can share what we see clients do and how to get started. So really, if we look at the state of the world, IT and tech, a lot of companies have a lot of pressure to digitally transform. COVID only accelerated it. But software engineers are a very finite resource, and only half of them work outside of direct technology firms like Azure, like Microsoft, AWS, or ISVs that produce software themselves. And we see a direct correlation between that gap of talent and the reason why a lot of digital transformation initiatives do not achieve the goal they want to. On the next slide, I wanted to talk a little bit about different approaches when we see our clients modernize their applications, how they go about it. So really, if you look, if instead of looking at it from a developer perspective, more from a running applications for a company perspective, when you look at it, you have a little bit of bandwidth of choices. Either you have a new app, then it's easy to build it cloud native, make it serverless, bring in a lot of the goodness that comes from cloud native event-driven architectures to your applications. When you look at your existing portfolio, you either have applications on the right here that want to stay on premise for a reason. Maybe it's data sovereignty reasons. A lot of our clients, they try to replace applications, maybe applications that they've bought from an ISV that used to run on an MSI installer on a virtual machine. They're going to be able to replace it with a SaaS offer. And then here on the left, this is really what we're going to talk a lot about. There is either migrate or modernize, or what we see a lot of clients say what they're going to do is migrate first and then modernize later. Migrating, easier because you're coming from an already virtualized environment, most likely. So we can really lift and shift you pretty quickly, helps you get out of your data center if that's the motivation, helps flip CapEx for OpEx. Modernizing, that's really going to shift the way you deliver your applications. And here you're going to switch from using infrastructure as a service more to either container-based or platform as a service-based approaches to deliver your applications. On the next slide, I want to make sure we understand the key drivers and when to do which. So as I said, in a world where we come from on-premise, and Nagendra and I and the rest of the team, we've done a lot of lift and shift in the past. But now we're really seeing the shift from, okay, we are actually in the cloud, we've migrated it, but it's not really hitting the KPIs, the business needs that we have. Let's talk about modernizing these assets. And why is that? Is because when you migrate, you're not really shifting anything of how you do it. So yes, you are running in the cloud. Yes, you have the benefits of working with a hyperscale provider like Microsoft. Yes, there are harmonized APIs in the way you can interact with Azure Resource Management. So you're really able to define everything, your entire infrastructure as code. You're able to bring forward really strong DevOps and governance with this. But if you think about the business needs and some of the KPIs that are expected to be hit for your long-term business goals, things like you need to reduce time to market, you need to reduce technical debt, the few developers that you have, they need to be as productive as possible. That's all going to be driven by modernizing. So really updating the existing application to be using newer computing approaches or newer application frameworks that simply, in most cases, cannot be realized on premise.
So Jerome, why is this? What does this funnel represent?
Funnel, I think it's represented the ease, as in migration. Yes, we can take basically all of your apps, and we've done this at scale where we can come in, we run tools on the hypervisor, we can find all of your digital assets that you have, and then tell you, okay, this is how they would run on Azure. So we can really take all of them. But the ones that we want to modernize, that's not going to be applicable to all applications. You're not going to want to recode or re-architect all of the applications. I think some of them will still live on infrastructure as a service, but a few really important ones, there it's going to be worth it to modernize and bring these new concepts in them.
Cool.
Yeah, here is Nagendra and I took a stab at kind of the post lift and shift challenges that we see, and that's going to bring us to the drivers of modernizing. So number one is always resources and constraints. It's only getting tougher, where either with the same or lower budget, you have to deliver even more from your tech team or your IT team. Standards and automation. Yes, you can define the entire infrastructure as code when you're on a hyperscale provider, but we still see a lot of clients not having used it to the full end. Some of it is related to them still having a core ops team that delivers infrastructure, and then a dev team that's not super well integrated into each other. And so they're struggling to bring this automation that would come with real DevOps, where the developers can really see the entire life of their asset from development, research, all the way to production. There is still an ask to continue to shorten time to market. And we're seeing more and more in a SaaS to SaaS world, where RESTful APIs are what you need to be able to be part of basically the internet, to be able to, maybe you have interesting data that you can capitalize on, that you want to make available to other people. Bringing these integration and RESTful endpoints is going to be a lot easier in a cloud native way. And then reducing technical debt. I have a lot of CIOs still telling us that, yeah, the lift and shift to Azure has not dramatically reduced the technical debt the way they would hope.
So like in terms of technical debt, this would be examples of security, the perimeter itself, but maybe it's also things like operational insight into what's happening, right? And actually, I guess another one would be like there's only so much streamlining you can do when you're stuck on infrastructure, right? You hit this bottleneck, and you can't really be more efficient than those building blocks because they're so large, right? It's a virtual machine as a building block.
No, absolutely, and oftentimes they're still running as a monolith, and so doing updates to it is always feels risky and
right.
So how modernization helps here. So I've talked about how you can flip CapEx to OpEx, pay as you go. It's even more so once you go to modernize, because now you can use compute as you go models where really you only get paid for the memory and the CPUs that gets allocated. And again, later on we'll have a demo of function apps, which is the serverless compute offer we have, where really you're suddenly you don't have idle resources anymore. So you're not paying a fixed stamp fee per month for your VM, but instead you pay cents on the dollars every time your function app runs. Then you can leverage the scale engines that come with serverless. So really, this is really scaling seamlessly. You step away from all the warm-up time of virtual machines to really using very, very quick scale engines. And then there's a very big argument to be made that you can enhance your organization's security and resiliency posture. And why is that? It's because even already when you use infrastructure as service, there's this shared responsibility model where we make sure that the virtual machine is up, the virtual machine is powered, all of this falls on us, and then you take over at the OS layer on hardening the OS, etc., etc. Now, when we do away from the VMs, we help you even further along the way. So you don't have to think about the operating system. You don't have to think about hardening it. The only places we interact is you tell us when should your code execute, what event, and who should be able to call it. And so you're really drastically reducing your surface of attack here. And ultimately, this is how you're going to manage to retire technical debt, because everything we do has the goal of making sure that your developers get productive as quickly as possible. So really, they can focus on writing code, on writing the IPs that advances your business goals, and then lean on us to help you run that code at scale in a secure way, jointly on this hyperscale infrastructure.
All right, so let's jump into a little bit more examples, right, like Jerome?
Yeah.
Enough of the death by PowerPoint. Well, actually, we've got more death by PowerPoint.
So this is let's talk a little bit about what are some of the drivers that will really accelerate modernizing. And so these are scenarios here that you either would be really difficult to achieve if you were still on infrastructure as a service, or you just simply couldn't. So for myself, a lot of the projects I get is customers that want to deliver their experience as a SaaS, so software as a service. Instead of distributing software, they want to host the customers that come and consume it from the cloud. And having the scale to be able to deliver to your customer in a multi-tenant way, you're likely going to use containerized workloads. You're likely going to use app services, because you're not going to be able to predict the load at any given time. So that's one where I do a lot of work with large film studios, for example, was one example.
And I had a nice example on like working with a customer that's doing real-time telemetry. So take a look at this diagram, right? So this represents basically a van that shows up, and it launches a bunch of drones. They all fly out of the van, and then they start sending in telemetry every 15 minutes. For every device, there's going to be maybe about 10 messages that are going to come in, but we can't actually process that message until we get all of them. So we temporarily store those messages into Cosmos using a connection from Azure Functions. And then when enough information is been processed or sent in, we send that into in the event processing, where again it's archived, but then there's some more processing going on before it goes into Cosmos. Now on the top side here, what you're seeing is that there's an application that gets notified. So users are on an app can get notifications if something out of the ordinary occurs, and they're able to log back in and using an Apim transact with either the long-term storage database or the recent data itself. And then there's machine learning that's happening on the long-term data that's coming in, as well as Power BI. So this is a typical example of an IoT kind of an application in terms of modernization. If you think about how this could be done in the IaaS sense, right? You know, you just can't anticipate the workload. It's a very different kind of an architecture to scale infrastructure as a service versus to scale modern applications, right? So these are all using PaaS and serverless services that can scale much, much better and actually have a very different cost curve itself. Another one to take a look at is actually, I want to show this example. It's actually going to be, and you guys have probably seen this, right? So if you're in PowerPoint, right, and you know, there's embedded AI here. So let's say I type in my my title, let's say flight patterns, right? You'll see that the designs that are coming up and being suggested to me are dynamic based on my keywords, right? So let's say if I had done, let's say board meaning, right, instead of flight patterns, I'm going to get something that's specific to, you know, something that I could present as a board meeting, but maybe that's board construction, right? So this is very adaptive. It's basically an example of how AI can be incorporated into your application, and PowerPoint does it very seamlessly. So I think this is a great example to show how you can take your current application and actually modify it to include AI.
Very, very cool. Yeah, the last two are probably so Geo Distributed App, where you need to launch an app in different regions. Maybe there are data sovereignty rules in Germany and Brazil that dictate that you need the primary copy of a data in a certain region. That's something where lots of clients will come and build cloud native because they can leverage the 74 plus regions that we have and operate and are still expanding. And then there's some really interesting one. We're not going to get into it, but we're still very much seeing a hybrid world where we need to be able to run workloads both in the cloud natively and at the edge. And with Kubernetes and containers, there are ways now to be able to bring cloud native Azure concepts down to the edge. That's going to be with Arc. And that's probably would be another hour and a half to get into it.
Maybe we can make a recording of that. I nominate you, sure.
So I did want to, this is going to be the one product slides that we have. And after this, we'll go into the well-architected framework itself. I just want to make sure everybody has heard these names, especially if you want to Google them or Bing them afterwards. How our portfolio is structured to help you modernize. If you came from the left here and you came from the .NET world, the Java, the Spring Boot world, any language, mainstream language, you'll be able to find a way to run it in Azure. And it will depend if you need more control or if you want your developers to be more productive. And that's what's represented here on the vertical axis. So more control, also the ability to run legacy code, it's going to be with Container Platform as a Service. So you containerize your application and you launch it. We have different offers. The most popular ones are definitely Kubernetes, where you have mainstream Kubernetes distribution, but with some bells and whistles that will help you be even more productive and secure your Kubernetes cluster. Or Red Hat OpenShift. We have a really strong partnership with Red Hat. If you're already an OpenShift customer, there's a really easy way to set up an OpenShift cluster in Azure. And now you can decide as you containerize, is it going to run on-prem on this cluster, or is it going to run in Azure on this OpenShift cluster? If we step away a little bit from the containers and use truly cloud native, that's going to be platform as a service, like the app service or Azure Spring Cloud, where we've built services with everything you need to be able to run your code. So all you're sending us, instead of sending us a container image, you're just committing your code, and then you'll have a pipeline deploying your code, and we'll make sure it runs no matter what language it is. And if it's already in the Spring Cloud, Spring Boot environment, we'll run this. I think Java and Spring Cloud is still some things that a lot of our clients don't realize we have as a first party offer in our cloud. And the last one, we won't touch much on it, but there's a huge influx in demand in low code, no code platforms. So Power Apps and Power Automate would be the offers we have there, where we see a lot of pro developers stopping and saying, hey, I don't need to reinvent a front end every time I want to do CRUD operations against my MySQL database. Why don't I have a Power App template and I can just reuse this every time I have a similar project? And that's where Power Apps and Power Automate will really help you. And you can still use the same application lifecycle management you would with your pro dev applications. You could with these low-code apps too.
Okay, so we're kind of at the end of the first section here. We've made a case why you should modernize, right? Obviously, there's a lot of technical debt that's kind of trapped in the architecture. And if you can modernize it, you can release that, right? You can open it up to be able to do that. So now we're actually going to talk about, you know, what well-architected, what the framework is. There are 5 pillars in it. We're going to talk about those 5 pillars and explain to you the real merits of those pillars themselves, and how they, later on, we're going to actually map those pillars to services. But for now, we're going to understand why those pillars are important and why you should think about them. And then, what are the tools that are going to be available to help you with that, right? So with that in mind, let's take a look at a typical lift and shift architecture. There's a bunch of VMs here. There's a load balancer. There's a public IP. Users come in via the public IP address and they hit this tandem of web servers. Behind the scenes, it connects to a database and an Active Directory. This is a typical scenario that we see all the time. Now, the database itself is backed up to a different VNet in this scenario, and AD actually has a backup as well. Now, this is lots of VMs, and these VMs are running multiple purposes. But if you think about it, you can't really scale at a unit that's smaller than the VM. So you might be using a particular service that's part of that OS, but you can't scale that independently, right? So when we think about, when we think about modern architectures, we're talking about using the PaaS and serverless services that are available within Azure, and how you can tie those together to implement the same solution. But done in this way, you have more fine granular or more of a fine granularity in terms of the building blocks. And so you may not need to scale your key vault, for example, because you're not going to hit it that much. You may only be scaling certain portions of this architecture, right? So when we talk about modern architectures, that's kind of, that is an example of what we mean. Now, but before we can get started, there's a couple of things you should already have in place, right? You should already have an enterprise scale landing zone. If you don't have it, this is come talk to us. We're going to help you to understand how to get that in place. We have lots of accelerators that are even available to us that we can help you to get started with those. We can point you to those. But an enterprise scale landing zone typically takes that large infrastructure and breaks it down into smaller components so that at the end of it, at the bottom layer, you actually have a landing zone. And the landing zone represents an application. And that application lives inside that zone. And so you're able to shrink wrap certain responsibilities into that landing zone. But outside of that, you don't have to think about for every application because they're managed outside of that landing zone. The other thing I'm talking about here is the governance tools. These are free services that are part of Azure, and you should make use of it. They basically help you to run your organization, your infrastructure, and so that you can get an idea of what's happening as well as enforce certain scenarios. If you click into this link, you'll actually go to the cloud adoption framework, which looks like this, and it will describe to you what is a landing zone. And the larger picture when I talked about enterprise scale, this is what it looks like. You'll have there's a certain enrollment for the enterprise. You have identity as a subscription. You'll have management as a subscription, and you have a connectivity. This is a hub and spoke model, right? So you'll have a connectivity subscription, and then each of your applications could be inside of a landing zone. So you can learn more about what those are by clicking into that link itself. So having said that, let's actually move into what is well architected.
All right. So well architected, really how it was developed was to help you, our clients, build workloads with confidence, knowing that you're using the right thing for the right job. And it's going to be centered around 5 pillars: cost, operations, security, performance, and reliability. And it's really meant to be actionable and simple to use, but still have a lot of technical depth to help you design your workloads. It's grown from all the engagements we've had in the past amongst our cloud solution architect community, and really condensating all that knowledge into one place. And then it also, with the well-architected assessments, and I'll show that in a minute, we want to help you focus where should you focus your activities and efforts to optimize your workload. So, for example, you might be really good at security, but maybe in cost, there is place to optimize. So this is meant to help you really zoom into where is there still room for optimization. So if we look at the 5 pillars, again, do you want to start with the cost one?
Yeah, so I'm actually going to illustrate the importance of cost optimization with an example. So I had a meeting with a customer. This is my first time meeting this customer, and the CFO was on the call. And you know, when the CFO is on the call, they're thinking about one thing. But this is what he said. He said, my problem is that my month-to-month Azure bill seems to be growing. What it was, the cost that I had last month was higher than the month before, and that month was higher than the month before that. And I cannot, and he said to me, he said, I don't know how to predict what's going to be the cost next month. So I asked him, you know, what was the expected cost? And at that point, the CFO turns to the IT director and he said, you know, can you answer that? And they basically looked at each other and they said, you know, we don't know. We never did that exercise, right? So this is completely illustrates why cost optimization is an important part of the exercise. You should not deploy something without understanding how much it's going to end up costing the business. Somebody's going to have to do the pros and cons of making sure that the cost justifies the business benefit, right? And so cost optimization focuses on helping you understand the cost, but also helping you to make use of things like reserved instances and or the hybrid benefit to be able to reduce the cost. And also it makes sure that you're auto-scaling services as much as possible so that you're not over-provisioned. And you've all heard the over-provisioning scenario, which is that, you know, you're provisioned for Christmas, but it's actually July, right? So you don't need all of those services.
Yeah, brilliant. Yeah, the next one would be operational excellence. So really bringing good processes and cadence with best practices from DevOps into the way you build and deploy for the cloud. And operational excellence, for me, it's always very intertwined with reliability. Because bringing a high degree of automation is going to help you reduce all the areas where the human can still do an error. When we do RCAs on larger outages together with some of our clients, the number one cause for these problems is still the human factor. Very, very much less the actual hardware failing or the electricity failing. It's oftentimes the human factor. So reducing the points where something has to be done manual is going to help both operational excellence and sort of reliability.
Yeah, and then performance for this pillar, the typical example I give is that, look, if the smallest scaling unit that you have, you can scale. You should auto scale always, right? But if you want to scale in a way that you're optimizing your costs, you're going to have to look at the design of your solution to be more granular so that you can have much more control over the parts of your application that are going to be scaling. Not only that, in order to hit the next level, next performance tier, there's a lot of design patterns that are defined as part of the well-architected framework. And we're actually going to be covering that a little bit later. But there's all these design patterns that are meant to help you understand how your applications can scale better. And so designing for the cloud is actually very different than designing for on-prem. On-prem, you were constrained to VMs and machines and physical hardware, and replicating that in your lift and shift model, you're going to be scaling or designing exactly the same way. But if you're modernizing, there are better ways to design your architecture and basically make use of more PaaS types of services. And that's what the performance efficiency pillar is really going to talk about.
Perfect. And the last one is everything around security. So how do you advance your identity and access management? How do you protect all the layers from the infrastructure, the application code itself, and then the data? So I always point this one out because I know a lot of our clients, they build an app and then they have to go to security for a security review. A lot of the questions that the security team is going to drill you on, they can be found in the well-architected framework. And actually, why don't I'm going to grab the stage and just show how that looks in real life, Nagendra.
Absolutely.
So where to find it? If you go to the browser of your choice and then the search engine of your choice, and just Azure Architecture Center. This is a place that I would really recommend to anybody who's an enterprise architect or a developer. Azure Architecture Center is going to contain a lot of different pieces of knowledge all around designing for the cloud, choosing the right technologies. For example, one diagram that's really, really popular is how to choose a compute service, just because there are so many different offers in Azure itself. There's this decision tree on when to choose which one. If we navigate back to the Azure Architecture Center, where we're going to go today is in the Azure Well Architected Framework. So here's the Cloud Adoption Framework that contains the landing zone designs that Nagendra mentioned. Azure Well Architected Framework is going to contain our 5 pillars and then introductory content for each of the pillars. A couple of more things I want to point out. So you'll have the design principles, the reference architectures. Those are valuable even if you were to build outside of Azure. In any hyper-scale cloud, they would be applicable. Our documentation is obviously going to be skewed more towards how to solve it specifically with Azure. Partners and support and service offers. So we have programs, and we'll talk a little bit more about it, called the Azure Modernization and Migration Program, where we can partially fund and go in together with a partner, and they've done it multiple times, and they have a really systematic way of looking at your application, potentially scanning the code, finding what is the level of compatibility to bring it to a cloud native or a function as a service approach, and then helping you build these out. So you don't have to go the whole way alone. And then we have the Azure Advisor and the Architect Review. I just want to point out the Azure Advisor. Think of the Azure Advisor, and you can go there today. If you don't know it, it's one of my favorite services. It's basically bringing all of the things from Azure Well Architected into the real world against your actual Azure deployment. So if I went to portal.azure.com, so I'm logged into my Microsoft subscription here, and I go to the advisor, I will get my score from advisor, where I can see, okay, how good am I across my 5 buckets again, and I can see in operational excellence, performance, reliability, I'm doing really well. In security and cost, I have room for improvement. And then you'll be able to drill into individual ones and see, okay, in security, there are a lot of things that I should address that are not really well architected. So Azure Advisor is going to be a way for us to surface these insights directly into your real world applications. And then the actual review. So this is something you can do before you build an application or after you've built an application as an assessment. And as I said, it should echo a lot what a security or tech ops assessment is within your company. If you're in the assessment, you can find there are different types here. We'll do the Azure Well Architected Review. And I start a new one today. Oops. Just to show you what it looks. So you'll give it a title. You say start, then you answer 2 questions. One is what type of workloads you're going to evaluate. So we're going to do a core well architected today. And then which pillar. And that's going to dictate what types of questions you get. So if I do an operational excellence, here are all the questions that are going to populate. And then the next one is you start right there with the questions. So we'll ask you, for example, have you identified and planned out the roles and responsibilities to ensure your workloads follow operational best practices.
You know, Jerome, thinking about that, I think some organizations have dual purpose, you know, or engineers or resources are typically dual roles or triple roles, right? So some of them are part of development, but also part of the, you know, operations to deploy it out, depending on the size of the organization, right? Is that something that's going to hinder people?
Yeah, so that's something that would be up for discussion here. This is the second bullet, actually. There's no separation between dev and ops, for example. And then you'll see what is kind of the Microsoft position on this, what is truly DevOps, for example. So clicking all of these might not get your score the highest. Some of these are considered good practices, some of these considered a little less mature. But as you go through it, you'll be able to, at the end, get results. So let me go back to the assessments and show you ones that I did in the past. So for example, this one. If we look at this assessment, it's completed, so I can go and click straight to the guidance, and you'd be able to rework your questions as you go. So it can be something where you grow the score over time. So this one, for example, I did terribly, was 24 out of 100. So there's critical room for improvement. And then when I look at the recommendations, I'm going to get the 39 recommended actions. And from here, I can click in any of these, and it will bring me right to, okay, this is how you would solve for this weakness in your application. So really good way to be able to continuously improve your applications as you go, bringing the best practices into the way you do work.
Was there a question online?
Nope, just commentary.
So this was yeah, the demo of where to find Azure Well Architected, how to use it out of the Azure Architecture Center.
All right, so let me take the share back.
Sure.
And okay, so actually that was actually the next slide, which is the assessments, right? So at this point, you know, the Well Architected Framework is very in-depth. We can't do it justice in the short amount of time that we have. There's a lot more technical stuff that's to follow. So from here on, we're going to be shifting to a lot more of a technical track. But before we actually get into that, let's talk about how can customer success help you, right? So typically, you know, we're cloud solution architects, customer engineers, specialists, customer success, account managers, support engineers. This is who customer success refers to, right? So it's an organization within Microsoft, and these are the roles within it. And we typically engage with customers to help them do architectural design discussion sessions. We help to build out maybe proofs of concepts, do demonstrations of products. Maybe we can do a rapid prototype. We can give you best practices and help educate some of your resources, your engineers. We've also got a cloud center of excellence where we can bring you in and run some deep dives into what is it that you're trying to build and give you some ideas on how best you can incorporate that. We also work with partners, and so there's a very rich ecosystem of partners, and we can bring them into the conversation. So there's a lot of times that we cannot go to the depth that's required in order for your proof of concept, for example. Well, we can bring a partner in, and they can dedicate a lot more time to go very, very detailed in a great deal of depth with you. There's also lots of assessments that are available as part of what we do, and so really the point of this slide is to help you understand that, as you know, well architected and migration and deploying into Azure is actually, you know, it's quite an intense activity. And so, but we're here to help you along with the whole process. Reach out to us if you've got questions. Reach out to us, and we'll engage with you. We will help to drive it forward, whatever your project is.
And the GitHub, I added your and my email addresses at the bottom. So if you want to get a hold or find out who your assigned cloud solution architect is, do reach out.
Okay, so having said that, we're going to be moving over to mapping Azure services. So let's talk about design patterns. Now, the Azure Architecture Center calls out a whole slew of design patterns. I'm going to cover 3 of them just so that you understand where we're coming from, right? So let's look at this ambassador pattern. So in this scenario, I've got maybe some legacy code that, or code that I don't have access to source control or something like that. Or I've got applications that basically didn't consider authentication or retry mechanisms. And so an ambassador pattern is actually a proxy that sits in front of your application, and it handles the request to the remote service on your behalf. The nice thing about this ambassador pattern is that you can actually add logic, you can add monitoring, you can add security. Things like circuit breaking, which is basically says that there's been a failure on that particular remote service, don't keep retrying it. Be a little bit more intelligent about when you retry it. Sometimes it's better to just return a failure, that the call failed, rather than to keep retrying it for forever, right? So the ambassador pattern helps you to understand when to bring that in. Another one here is claim check, right? I've seen this a number of times where the producer is actually treating the queue as the data source, right? They're sending multi-megabyte messages to the receiving application. Now, the downside of this is that you can only scale so much on the messaging system before you're going to hit a bottleneck. So in order to open up your performance, you actually store the data in the data store and put a reference to that data store item in the queue. And then the receiving application receives that reference ID and then can go look in the data store. Now, you might think that this is only for performance, but actually, if you think about cost optimization, messaging systems are not typically scaled for storage. And storage, on the other hand, is actually priced much better. So if you're storing the large component of your message in a data store, and only utilizing the messaging system for the very small message number of bytes that refer to that item, you're going to have actually a lower cost, right? So it's important to understand the claim check pattern. Another one is federated identity. I think everybody on the call must know about this. This is the concept that the token, the calling application or user gets a token from the identity provider, and the application can actually ask the identity provider to validate that claim, that token has the appropriate privileges. Doing this basically alleviates the need for that application to do some validation, and actually keeps security inside the security privileges and credentials inside the identity provider. It's actually a very good security model to do it this way. And again, the reason is because it takes the security perimeter and puts it outside of AD, whereas inside your service, it's not there. So your app developers won't have access to end user credentials, for example. Now, there's lots of these patterns available, so I'm just going to very quickly show you what they are. If I click into it, it'll take us to let's try that again. Okay, let me bring that down. So it'll actually take you down to the design patterns, and they're broken up to data management, design and implementation, and messaging. But actually, you can actually, if you scroll down further, you can actually see the full catalog of patterns, and you can drill into each of them. So, for example, I looked at Ambassador earlier, right, to explain that to you, but you can click into it, and it gives you the context of the problem, it gives you the solution, and it gives you some more ideas on what you should consider when using the pattern. And so it's a very rich resource available to you. You should make use of it as part of your modernization journey. So now let's move over to, so after you've looked at the design patterns, right, let's actually take a look at some of the popular PaaS services. So this is actually where we're going to do our first demo. And the reason I'm going to do this demo is because typically when we talk about PaaS services, people ask us, well, that's all good, to have these PaaS services available, but what is the performance of something like that, right? Like we say that you can increase the responsiveness and operational efficiencies and lower your costs by using, for example, Azure Functions. But people say, well, like how reliable is it, or how performant is it? So I thought, maybe to best illustrate that, let's just do a very quick benchmark of that, right? Jerome, I wonder if you can time us, because what I want to do is I want to take maybe no more than a minute to see what I can do for this Azure function. So just to get you guys, like to show you what I've got, I have this Azure Functions has, once you integrate it with App Insights, it has this feature called Live Metrics. And Live Metrics shows us the current, that's, all right, let's try that again. So if I go back to my function, that's what happens when we do live demos. So let's go to, here's my App Insights, and I'm going to go into function. Let's actually activate the function. Maybe that's what's causing this.
So when you do use these platform as a service offers, it will come with everything we would recommend to do, monitoring and live metrics.
So it looks like I've got an issue with the live metrics server, but there is a recording of it in our video. If you go into the video folder, you'll see that there is oh, there we go. Okay, so it's finally coming up. So at this point, what I'm going to do, what this is showing is my incoming request rate, and this is also showing me the number, the duration of each request, and along with failures and things like that. It's showing me how many servers are online available to run this these Azure functions, and on the bottom of the screen, I can actually see what the server IDs are, as well as what the CPU is on each particular server. So as part of this test, what I'm going to do is I'm going to try to do, I'm using Apache Benchmark, and I'm going to basically from 3 different screens try to send a large load into it, right? So once we have done that, we should be able to see here, it's starting to scale up, and looks like I'm hitting over 400 requests per second against this this server. And again, look, this is going to depend on how I test it. So in my case, I'm testing it with these 3 instances. This one finished. Let's start it back up again. I'm actually just testing it with these parallel connections here. This one is doing 50 parallel connections. This one is already done. It's doing another 50 parallel connections. This one is 50 again. And so basically, my Azure Functions, what this should illustrate to is actually quite performant. All of these response rates were under 300 milliseconds per request. There were no exceptions, right? And it's actually, we've captured all this log traces, right? So we can actually go back into the logs and actually see what happened with each of them.
Yes, and then it's scaled out now to 7 instances. And I think when we first got here, it was at 1 or 2 instances.
Right. Now, a note on that, by default, Azure Functions can scale out to 200 instances, and I'm sure you can raise that upper limit with by issuing a support request. But just imagine this. Here I'm making like 150 parallel connections and trying to slam against the server, and I still have only hit 7, right? So if I can get to 200, that would be a massive scale. All right, so back to, so that's the, if you want more details on that, you can watch the video that we have online that shows a little bit about that. Now, that should give you a little bit of an idea of the scale of these things. Event Grid, Event Hub, all of these things are very, very high scale services, including Apim. App Service scales independently. Cosmos DB is another one. This one can scale around the globe, right? You can set the consistency levels of how you want that data to be consistent. We'll have videos and more demonstrations in the online link for you. So now let's actually do a little bit of a shift into looking at the different types of services, right? So compute in Azure, right? So it depends on what your workload is, right? Whether you've already got a Java service, whether you're using OpenShift, Spring Boot, or maybe you're using Kubernetes already, right? You can bring them right into Azure. You can also use Azure Container Instance, which gives you very, very scalable way of deploying containers that are going to be short-lived, right? So, for example, I have a containerized web app. Maybe it's going to be Perl inside Apache, for example. So I can containerize that and I can deploy it. And Azure will scale that just as it scaled the Azure Functions. It'll scale it. It'll bring runtimes online based on the load, right? So that this is available for if you've already got containerized types of workloads. You can also deploy in a web app, and a web app has different plan tiers, right? Free, shared, basic, and standard, depending on your needs. So if you need it to be integrated into a local VNet, for example, you might choose a different type of a plan based on that. But here it can independently scale. So think of a web app as a website. Maybe this is the layer of your application that's just going to be the front end, or maybe it's the API layer. It can independently scale. And we actually just saw a benchmark of Azure Functions. But the real cool thing about Azure Functions is got this binding, input and output binding. There is a demo on this. You can look in that. But the binding allows the function, when it runs, to actually have data prefetched. So the function will get called, and Azure will have prefetched the data that you have wherever you've connected that function to. And on the output binding side, if you create a record, it'll take care of writing that out. So if you think about the errors and things like that you have to handle when you're writing your code, well, Azure Function not only does it make it very elastic, but it also makes it more convenient by adding this input and output binding capabilities. Now, if you're interested in choosing, right? So sometimes you don't know which one to use. So this is where you have this this flow chart. And Jerome, you showed this earlier. This is a very different view of the same thing, but it's kind of laying it out. You know, look, I'm going to have virtual machine, or I'm going to use batch services or logic apps, or I'm going to use a web app or an Azure function. If we have time, there's actually a bot that does this for us. We can show that if we've got time today.
That's great. Should we talk a little bit about messaging and eventing?
Absolutely.
So this is still, I think, a topic where we see a lot of design sessions where we discuss, okay, what's the difference between the service bus, the event grid, and the event hub? And they are very different, and they're meant to be used very differently. So I think at the center is understanding the difference between a message and an event. A message is really raw data that's produced by a service and consumed by someone else. And the publisher of that message has an expectation of how that message is going to be consumed by the consumer. So you really have a handshake where there's an acknowledgement that you received the message, you've done with it what you were meant to do, and the sender acknowledges that, and you have this contract from both sides. An event is something very different, where it's much more of a lightweight notification that something has happened, a state has changed, and the publisher has no expectations of the recipients. So you can have hundreds of people, of services listening to that event. The producer of the event might not even realize how many are consuming that event. So with that said, the service bus here on the top left, that's an enterprise-grade message service, fully managed, where you have topics and subscriptions, and then you can do things like guaranteed first in, first out, or patterns like this. That's going to be for applications where you might be doing, for example, a payment structure, where you want to really have high guarantees on message being received, message being processed in the right order. And then you also have a dead letter queue that will enable you, if the consumers, for example, they can, a consumer will be able to lock a message. That means that other consumers can't grab it because he has it locked for himself now. He'll try to process it. If he doesn't process it in the time needed, then it reappears in the queue, and another consumer can try and grab it again. And if after a certain time it's still there, the message, because no one is able to successfully process it, then it can be shifted into a dead letter. And then you can have another sort of logic say, hey, we have this payment, we tried to do it 5 times, it doesn't work, something's wrong. So that's when you want to use the dead letter queue. On the right here is the event grid. The event grid is really interesting. So that's really an eventing backplane that enables really event-driven reactive programming. It's actually what powers all of the backbone of Azure services talking to one another. And we've made it so that you can build your own events using the same technology, using Event Grid. So you see all of the event sources. Everything in Azure can be used as an event source. Everything in Azure can be used as a handler receiving those. But you'll also I have clients do cloud-to-cloud events with this, where they'll have topics in AWS waiting to consume an event from that originated in Azure, for example. So that'll be a super nice, lightweight way to really build event-driven architectures, where maybe your compute instances only spin up based on events that they consume. And then the last one, Event Hub, that's a little bit different. Think of more Kafka, but from Azure native. So that's really a data streaming platform with really large ingestion. It can really scale out enormously, millions of events per second we're talking here. And then what you can do is things like capture, retention, can even replay. So that's going to be more for use cases where you'll want to use, where you want to do IoT telemetry, for example, and you'll want to be able to talk about reliability in your application, where you'll want to be able to really burst a ton of telemetry data from one place to another.
That's a great description. So I guess the key here is to pick the right technology based on what your application is trying to do, right?
Yeah, absolutely. Yeah.
And that boils down to the design patterns, right? So we just talked about how, let's say, messaging service bus can scale because you have got these sub-second delivery requirements. This is not where you want to store megabytes and megabytes of transaction data, right? Cool.
No, I think that's where your pattern, the claim check falls in, where actually the payload is a pointer to maybe to the actual raw data that's somewhere else in a more scalable implementation.
Right, and in Event Grid, you can use this to route, let's say, events, transactions around the globe, right? Pretty much.
Yeah. Yeah.
Right. So let's move on to the state store, right? So, a lot of applications use SQL or MySQL or Postgres, or there's a whole number of other databases that are available in the marketplace. So depending on what you are already using, there's going to be this type of server available for you. Now, but one thing to keep in mind, if you're talking about the database being, here's a database server, so we're talking about a VM where you deploy the machine itself and you deploy the server. That's different than, for example, SQL managed instance. Managed instance is an example where you define a VNet and a subnet, and then you tell Azure, hey, I'd like SQL to be inside this subnet. And then Azure will manage that for you. So there's something called MySQL Flex Server that does it for MySQL and Postgres. And then for SQL as well, the managed instance capability allows the scaling and the patching and the updating all to happen behind the scenes, but you still control the boundary of that database itself. Cosmos database is actually a very different kind of it's Mongo database, but really the key here, I actually had a conversation with the product manager for Cosmos, and he said, look, the best way to describe it is that we took Mongo database, the source code for Mongo, and then we added 60 engineers, and we added 6 years of development to it in order to productize it so that it can be planet scale, in the sense that your database can actually scale around the globe, and it's going to have sub-second or like 7 millisecond or 5 or even lower transaction rates to be able to do reads and writes and scale behind the scenes for you. The way Cosmos works is that you define a resource unit, and you say that my resource unit is, let's say, 10. And what Cosmos will do is it'll scale behind the scenes around the globe for you to be able to handle 10 RUs a second. And if you ever try to use it, each transaction has an RU count. If you ever try to use more than you're scaled for, Cosmos pushes back and says, you've exceeded the RU threshold, you should try it again. And the reason it does that is because you're not scaled for it. It gives you a very easy way to scale your application based on your throughput requirements. And when you get this scenario where something is not going to succeed, you just retry. And it will succeed because at the end of every second that counter resets. Another thing to think about within Azure is Redis. So this comes up a lot. We have a lot of different SKUs available for deploying Redis. And Redis is, if you know about it, it's just a read-write cache. So a lot of times web servers will just use a cache server to store a configuration information or the current state. For example, you might have a farm of web servers, and they're storing what the user's latest transaction was, and they put that into the cache. So now if the user comes back and hits a different web server, they basically look into the cache to see what was the current state. So Redis cache can scale to 200,000 connections, which means that your web servers can hit it in a very, very high scale. And so very large scale websites, shopping sites, things like that can be implemented with Redis. There are other state store services available as well. So you can explore those. So Azure Blobs, Azure Files, and Azure Table Storage are some other alternatives for storage.
Very cool. I think the coolest thing about Cosmos is also having multi-master replications, so you can have multiple masters distributed around the world. So for hyperscale online shopping platforms, I've seen that be very, very useful.
Cool. And the consistency level, right? To be able to say eventual consistency or strong consistency, right? So there's a whole scale of that and then whatever's in between, right?
All right, let's talk a little bit about a couple other that are not directly compute services themselves or state store. Nagenra calls them glue service, and I liked it so much we kept it. So think of it like this: when you are gonna invest into microservices architecture, where you now have multiple little blocks of code executing on their own schedule based on their own event, a lot of the shift of your engineering and skill needs to go into the orchestration and the monitoring of these so that you can really have this seamless scale. And that's where you're going to use these 4 services mostly. So top left is API management, and we'll do a quick demo before we wrap up this call of API management. So this is a hybrid service that you can run both on-prem and in the cloud to manage your API across multiple environments. It comes with an API gateway, so that's going to be a front end where you can direct your requests towards. A management plane, that's the one we're going to explore, and a developer portal. So what's really cool about API management, we've also anticipated that most likely when you build API, and a lot of our clients have these large projects where they're harmonizing APIs across their company, they'll want to be able to manage both internal and external stakeholders. And the whole life cycle can be done in API management, where you create the key, somebody subscribe to an API, you give them access, you want to be able to throttle them based on request. That's going to be all done in API management. The next service, top right, I was saying monitoring becomes super, super important in microservices and event-driven architecture. So that's going to be a service that has everything you need to maximize the availability and performance of your application. So it hits, again, the performance and operational excellence pillars of the well-architected framework. And really what we're trying to surface to you is a comprehensive collection, analyze, and ways to act and react on telemetries that you get from your Azure environment. So it's going to be telemetries that's coming from the actual underlying compute that we are hosting for you. And then you can even enrich this with custom signals and signals coming from your applications themselves. That's going to be the application insights. Here at the top left of the slide. App Insights, so that's a feature in Azure Monitor, really focused on application performance management. So on top of enriching the metrics and the telemetry that comes from the underlying infrastructure on which you're running your applications, you'll be able to add keys that will be enable you to trace end-to-end certain calls in your application. And really, that's going to be able to, for you to make sure that the user experience is really nice. What you see here, for example, in the middle layer, is what we look at for end-to-end transaction tracing. So think, for example, somebody logs into your front end application that's hosted on an app service. And now they're going to do certain actions that are going to result in API calls that are going to trigger Azure functions. And then the Azure function is going to go and make a call to a SQL DB or to Cosmos, wait for a response, get a response, give your user the response that they wanted and were waiting for. With end-to-end tracing in an application insight, you're able to see each of these steps individually. So we trace one REST call across the entire fabric of Azure and back, and then we can tell you which parts took how long, and we can find when suddenly some do take longer than expected. And for you, it's also going to be really useful to tweak and tune the user experience to make sure that the REST calls all stay nice and snappy. So I highly recommend Application Insights. And then the other one that is really exploding in popularity is everything around managed identity. So again, microservices means really decoupling your compute, but now you're making calls to other services, and you need to be able to still identify, right? Identify yourself to authenticate. Then this way you can do the authorization against each services. And so the way to bring role-based access control to these microservices types architectures is going to be with system-assigned identities. So you can trust Microsoft, or you can trust Azure and trust Azure and set it up yourself, where we'll say, okay, if this function app calls this database, whenever I spin up a function app, it should have this system assigned identity. And then I'm going to tell this system assigned identities that, yes, it's allowed to retrieve that data from that system, for example. And so really here, you can eliminate a lot of the code you would need and the credentials you would need to usually ship with your code so that your systems can authenticate and have connection strings baked in. All of this you now take out of it and let the fabric of Azure manage a lot of it. So it helps a ton. You also don't shoot yourself in the foot when you rotate secrets and you didn't realize you had some hard-coded in your code, for example.
You know, Jerome, the managed identity is great, but there's one thing about it that I really don't like.
What is it?
It's not available for every service.
Gotcha, yeah. Well,
So it's coming, right? The roadmap is there. Like most services have them, but I just wish it was there for every service because it's so useful.
Yeah, I hear you. So I thought I could do a quick Apim demo, maybe on the next slide, or I'll take over the share. All right. So I did want to show a typical, at the beginning we were talking about, here's IaaS on the left and how it could look post modernization. And post modernization, most likely you're going to put your front end of your website on an app service, and then you're going to put some of your business logic on function apps. So here, for example, we have the products API, the users API, and then we put them behind API management. The beauty of it is that there's threefold. Number one is now your backend can scale individually from your front end. So you don't have to scale the entire camoodle here, but Azure will scale these as needed individually. So if you're, for example, a restaurant and you get at lunchtime, it's crunching your APIs, you'll be able to scale these APIs individually. So probably a lot better UX. The next one is that you can build polyglot applications. And that's actually something we see everywhere growing, is that you have applications that continue to grow, but they're not all written in the same language, and they don't have to be. So you can have maybe your front end is React Native, and then some of the business logic is still .NET. And then there's an AI API that's been written by a team of interns last summer, and they wrote it all in Python because that's what they love the most. And so you can have here Python API, C# API, and it doesn't really matter. API management will be able to call them individually. So you build Polyglot applications, and then you also, for the lifecycle management of your applications, you can ship individual updates to these backends or to the front end, and you don't have to test the whole thing all together anymore. So you can make these small updates and have confidence that it's not gonna tear down the whole thing. So let's look at the API management service. So I'm over here in Azure Portal on my API management service. This is a consumption-based one. So that means that when there are no calls, there's no cost. And if I look, I want to make sure we all know the concept of APIs, products, and subscriptions. So APIs, I can add my APIs here. I can either, if you have them already defined in OpenAPI or WSDL, you can import the definition here. Or if it's a service that's already in Azure, you're going to be able to browse for it. So for example, if I look for my function apps, I can browse my subscription and then find my modern product API, for example, select it, and then I give it an API suffix, for example, API/product, and that's all I have to do. And then when I click create, it'll onboard it, and then I see it over here. And it will onboard it, for example, if I look at my products API, it will onboard it with the operations I can do against my function app. So the whole definition is taken care for you here. And I have the concept of products and subscriptions. So products are going to be a collection of APIs, and then I'm going to give subscriptions to a certain APIs products. This is what you're going to use to manage your users. So if you had like third-party developers, they want to have access, be able to directly put orders into your system, for example, you're going to be able to give them a subscription key. That's what they use to call your dev or your production APIs. And then another beauty of the API management service is that we have this concept of you come in through the front end, and then you have inbound and outbound processing before you hit the back end. And then if you look at here, the policies, it's going to be this XML file. I wanted to show you the design actually first. If you click on add a policy, you'll be able to add things like IP filtering, limit call rate, which I would highly recommend, so that if there is unhealthy code written by a third party, they can't call you 15,000 times a second and then tear down your backend, for example. You'll be able to give mock responses, so that's when you want to have developers be able to already call your API, but your backend might not be ready yet. You can leverage mock responses. Can set headers, you can hide some fields so that on the response, for example, there is no way to see that it's actually SQL backend implementation, for example. And then if you want to test it, let's actually test the other one. I want to be conscious of time here. If we do modern user API, you'll have here this test blade right baked in. You could do this from Postman, obviously. But if I call it here, I don't think I need a request body, but you're the one who wrote the APIs, Nagendra. Yeah, I didn't need one. I get a 200, okay. And then I get the payload here, username, country, where they are from, etc. So that's API management. I've done one more thing. I've actually onboarded a logic app. I just wanted to show logic app as a really cool way to bring low-code, no-code approaches to your implementations. Logic app is going to be able to do this for you, where you have, again, a serverless approach. You go to your design blade, and then you're going to have a drag and drop experience to build your own flow. So here, for example, I've created one that is expecting an HTTP request with a string, a field for contact, and then it sends an email with the contact and then some static text to Nagendra, for example. And so I've onboarded it here again in my API management. And then if I call it, for example, I'm going to say Jerome, and I send it, I get a 202 accepted. If I come back here to my API management, I refresh, I get the built-in monitoring. I see it's at 1:20 today. I sent something, and if I looked at my email, I would see that Nagendra should have gotten an email that says, hey, Jerome needs help from you. Please get in contact with him. So this is a 5-minute way of adding a contact API with a mail server to your implementation.
I actually got the email.
Brilliant.
Since you have the shared, oh, okay.
Yeah,
so,
I'm happy to share. I'll keep going.
Yeah, just keep going. So Azure Integration Services. So, this is actually a collection of we've covered these services before, but what do we mean by integration services? So this is the list of the 6, right? Basically, logic apps, functions, Apim, data factory, where you can extract data from databases, SQL database, and you can move and process that data in real time. Event grid and service bus. So when we talk about Azure integration services, we're referring to these services because they typically get used to connect one subsystem with another, right? So just keep that in mind, right? Now, on the AI side, we talked about AI so much in the beginning, right? But there are actually a lot of tools that are available to you as well, depending on the language, whether you're talking about, let's say, look at the frameworks, right? PyTouch, obviously that's in Python, TensorFlow, Onyx, it's basically what your data scientists are used to using, but there's something available on that front as well. Okay, so having said that, let's just move over to the next slide. We're kind of at the end here of mapping the services. This is by no means everything, obviously, right? Azure has over 200 services, and we're more than happy to help you with it. But I think the most important thing, the most important point right now is engage with your Microsoft team. Please find out who invited you and contact them, or even us, right? In the link below, there is a URL you can click on to get in touch with both Jerome and myself. You can use that. You can engage with the team directly, or you can peruse all the other information that's available. So we've got technical docs available for all the different things that we talked about today. There's hands-on labs, hands-on labs, as well as training materials available. There's modernization and migration assessment tools available as well. So all of those are captured here. So please please take a look. Jerome, maybe we can click into that URL at the bottom, because the next thing, there's only one more thing I wanted to just point out, and that's so when you click on that or it'll take you to the GitHub repo. At the you see there's a folder called demos. So when we're talking about the demos being available, this is where we're going to be storing them. Right now, we've got 5 of them, and these are kind of pretty much in depth. This is where you can actually go in and look at a lot of the details of what we're talking about. There's step-by-step walkthrough of how you can do it yourself. So have a look at those. We're also going to be adding over time. So check back frequently and subscribe there.
With that, I think that wraps up. I see we still have all of our guests here. If you do want to, feel free to come off mute and let us know if there are ways you want to engage us already at the end of this call. I think we have another 6 minutes. Oh, Joe, very good question. The main slides are also in the GitHub. This is going to be where to download them.
Jerome, are you sharing?
Oh, no, I just dropped them in the comment section.
I was just shamelessly pandering for the slides to be listed.
You can get these are the PDF. I'm happy to give you the PowerPoint itself.
So, in case if you've got other people who would be interested in it, let us know if you're interested in further details. We're more than happy to go into a deep dive in any of the sections that we talked about earlier, as well as